Fertilizers are chemical compounds that are given to the plant to improve and promote growth. Most of the time, fertilizers are applied to the plant through the soil so that the roots may take up the nutrients, but can also be given to the plant through the leaves via foliar feeding. Fertilizers can be organic or inorganic. Organic fertilizers, like manure, peat, and sewage, occur naturally through living processes. Inorganic fertilizers, on the other hand, are composed of minerals and simple chemicals. Both types primarily contain nitrogen, phosphorus, and potassium, secondary chemicals including calcium, sulfur, and magnesium. Nitrogen keeps the plant green and plays a major role in boosting growth, and hence the crop yield. This means that plants with healthy levels of nitrogen will have rapid growth, lush, dark green foliage, and high seed and fruit count. Potassium and phosphorus are also needed in the plant and are used in many of the structures and tissues inside. The use of fertilizer has been around for centuries in the form of manure, cinder, and other trade byproducts, though not refined until the agricultural revolution in the 19th century. In the late 1800s, the chemist Justus von Liebig contributed to the understanding of plant nutrition by disproving the vitalist theory of humus and pressing the importance of inorganic materials like other minerals and ammonia in the soil. In the 1880s, Jean-Baptiste Boussingault showed the importance of nitrogen in the soil. Other innovations were made into the 1900s, including more efficient processes and more refined chemicals. Inorganic fertilizers can be divided into two categories, macro and micronutrients, based on their concentrations in dried plant material. Macronutrients are the main elements which are needed by a plant: nitrogen, phosphorus, potassium. These are known as NPK. The micronutrients are the secondary elements that a plant, as well as most life on Earth, needs, but in small or trace amounts, some of which are iron, copper, and zinc. Inorganic fertilizers often do not replace the trace mineral elements in the soil in which the plant is being grown. This means that they will be gradually depleted and lose the ability to successfully sustain life or normal plant growth. Other concerns about runoff and accumulation of different trace elements, either by natural byproduct or through processing leftovers when the manufacturing process took place, has been raised. Often when no cleaning process is applied after growing and after mining and production, traces of heavy metals accumulate, which are then absorbed by the plants, which in turn are absorbed by anything that consumes it. In the cases of all fertilizer, too much can be just as bad as too little. When exposed to high levels of the mineral and chemicals used in the fertilizer, plants may be killed or have their growth inhibited. Some fertilizers will release nitrous oxide and ammonia gas after application and decomposition, both of which can potentially harm the plant. Most fertilizer-related issues can be avoided by careful application and monitoring of the soil balance after application and growth. There have been many concerns with the production of inorganic fertilizers, as the need for them has been increasing with the population, but the methods used to harvest the materials, e.g. mining, are not renewable. This means that the production of these fertilizers in their current state cannot continue indefinitely. The fertilizer industry is close-knit with the agricultural industry, or the production of food and goods through farming and forestry. In 2000, 12.92 million tons of fertilizer were sold in the United States alone, and the amount continues to rise here in the United States as well as around the world. Today, there are many different companies that supply fertilizer, each with their own different formulation or a multitude of different formulations for different growing condition and plant needs. Major companies include Ipswich and Yara International. Fertilizers, while beneficial to plants in a majority of cases, are not a fix-all for growing. Many other conditions must be successfully met in order for plants to grow and prosper. Carbon, hydrogen, and oxygen from the air, soil, and water must be readily available, as well as direct light from the sun, in the case of all plants, for them to perform vital functions like photosynthesis. Other plants, for example, may require more specific quantities than a different species of plant. Corn, for an example, needs much less water than rice does to grow. I hope you have enjoyed this iMovie and learned a lot about fertilizer and its use.